Hi, my name is Trevor and welcome to this video about anisotropic surfaces in GeoStudio. Anisotropic surfaces can be used to generate directionally dependent shear strength. Soil and rock exhibit anisotropic strengths due to the presence of discontinuities where the strength of the discontinuities varies considerably from the surrounding intact material. In contrast to a weak layer, an anisotropic surface does not impose a direct control on the shape of a slip surface. Anisotropic surfaces are defined using a background mesh in 3D. The input properties of an anisotropic surface include a base material representing the intact soil or rock matrix, a material representing the discontinuity, and two angle ranges, A and B. The A and B parameters associated with each anisotropic surface are angular tolerances around the discontinuity. These control the transition of shear strength from the anisotropic material to the intact material. The solver calculates the shear strength based on the angle between the column base and the anisotropic feature. Within the range of A, the discontinuity shear strength is used. Outside the range of B, the shear strength of the base material is used. For angles between A and B, the shear strength is computed based on a linear interpolation between the shear strengths of the base and the discontinuity materials. You can see a figure depicting the different search techniques available for anisotropic surfaces where the reference point is the midpoint of the column. Alpha is the angle of the anisotropic surface at the point found either horizontally closest, vertically closest, or closest overall. Let us get into the workflow for creating and drawing anisotropic surfaces. We create anisotropic surfaces by importing a background mesh and then assigning that to an anisotropic surface. So I go up to the Import button here, and I go down to Import Background Mesh from File. And I have my OBJ file here that I'm using as my background mesh called shear plane. You can also use STL, DWG, and DXF files for background meshes. The background mesh is positioned incorrectly in GeoStudio space because it was created with a different coordinate system. I can use the same transformation template I created when I previously imported the other geometry elements into 3D GeoStudio space. If I don't have a transformation template saved, I can use the Remap Axes tool. In this case, I would change positive y to negative z and positive z to positive y, and then press the Adjust Base Point button to bring the lowest point in the overall domain to the origin in our 3D space. So now you can see in the Geometry Explorer under Background Meshes, Static or Imported, I have the shear plane background mesh. If I turn off the visibility of the other geometry elements, you can see the background mesh in the domain. Now that I have imported my background mesh, I can go to Define, Surfaces, Anisotropic Surfaces, and click Add. I select the background mesh I imported and click OK. Now I can select my materials. My base material is my intact material, and I want this to be glaciolacustrine clay. My anisotropy material is the shear surface. I have already created this material called anisotropy material. If I click on the ellipsis, I can see the properties. I have set this to a friction angle of 9 degrees. I close the Define Materials dialog and switch to the Properties tab of the Draw Anisotropic Surfaces dialog. I set my angle A to 3 degrees, and I set my angle B to 6 degrees. The closest distance search mode is the default. You can click on the drop-down to access the other search modes. Now I close the anisotropic surfaces dialog. That is how you define an anisotropic surface in a 3D stability analysis. Thank you for watching today, and I hope you enjoyed the video.